Hello and welcome to this R tutorial. And now we are ready to move on to the next step, which is to fit our polynomial model to the dataset. However, I would like to show you how the polynomial regression model is a much more powerful model for our situation. And the best way to show you this is to actually compare it to a baseline model, like a reference base model, which will be our linear regression model. That's why in this tutorial we will build two models, the linear regression model and the polynomial regression model. And then we will compare the results, we will compare the graphic results and also the predictions. So you'll be convinced that the polynomial regression model is a much more appropriate model for this problem. And the main reason for that is that our problem is a nonlinear problem. Okay, so let's start by building this linear model. It's going to be very quick because we actually already did this. So we start by creating our regressor that this time we're not going to call regressor because we will build two regressors, the linear one and the polynomial one. So we will call it linreg. Here we go. And then later we will call our polynomial regressor polyreg. So linreg equals, and then remember we have to use the LM formula. And so we need to add some parentheses here. And then let's remind ourselves what we need to input by pressing F1 here to have a look at the arguments. Okay, so remember the first argument is formula. So the formula is very simply the salary that is our dependent variable tilde. So I just pressed Alt N and then a dot here to take all the independent variables, but actually there is only one independent variable. So the dot here is strictly equivalent as just writing level. Okay, so perfect for the first argument. And then what is the second argument? It's data. So data, okay, so let's add this argument. Data equals, and now let's see. Okay, so in the linear regression section, we actually used the training set here as the data argument to train our linear regression model. But as we explained before, here we did not split the data set into the training set or the test set. So we are simply going to train our model on the whole data set itself, because it's a small data set anyway and we want to have the most accurate prediction. So here simply we will just input data set. Alright, and our linear regression model is ready. We are actually ready to build it, so let's just do it. Let's build our linear regression model. I'm pressing Command and Control plus Enter to execute. Alright, linear regression made. We can have a quick look at the summary here. Summary linreg. So I'm typing this in the console and pressing Enter. And here are the statistical results of the model. We're doing this on R because, as you can see, it's really easy. On Python, we would have needed to import a class, create an object, but here it's really easy. So we can have a look. And we can see that the level has 2 stars here for the level of significance and is actually not a bad predictor of the salary. But wait for the polynomial model to see how it's going to be much better than linear regression. Okay, so now let's move on to the next level, that is the better model, polynomial regression, and let's build it. Okay, so as I mentioned, we're going to call this regressor poly_reg. Alright, this way. And since the polynomial regression model is actually a multiple linear regression model in which the independent variables are actually the polynomial features of one independent variables, as Carol explained in the intuition tutorial, well, we're going to use again the LM function as we did for linear regression. So here I'm just going to start by taking my LM function, add the parentheses, and we're going to input our two arguments, formula equals salary tilde, alt n, and then this dot here. But don't worry, we'll actually represent something else. So far I'm just putting the dot and you'll understand what's going to happen next, which will make our polynomial regression build correctly. So then comma, and then we add our second argument, which is still going to be the data equals data set, because we're going to train our polynomial regression model on the whole data set. Okay, so now you must be telling yourself, wait, but this is exactly the same as linear regression. Well, that's true, and that's why we need to add a little something here to make this model a polynomial regression model.